first session of the Data Club for the fourth semester 2025. I believe everyone is new, but actually we have a Data Club registration page. And if you want to come back again next semester, we might provide different contents. So just for your information, this is not repetitive contents every semester. So we always try to use this opportunity to collect people's questions, interests, then turn into different sessions. And I will be the host, or we call it facilitator, for today's session to talk about getting ready, started with research data. I will basically talk about concepts, tools, and resources, even though you think they are very basic, but I assume all of you here today, you are from different backgrounds, different majors, so your understanding about data could be very discipline-oriented. And my goal today is to broaden your mindset. You will hear something you feel familiar with, but I assume you will also get something new. And if you have any questions, don't feel hesitated. Just stop me and ask that questions you feel interested, because we want to make it as a communication rather than I'm a teacher, I try to educate you. My name is Wei Ying. I'm the Research Support and Data Services Librarian at Research Data Services. And today, let me introduce my colleagues. So we are all Research Data Services, Eric, Monsieur, Jerma, and myself. And I have introduced myself, and I will ask the rest of them to have a brief introduction about themselves. Then maybe if some of you want to introduce yourself, we can do that. And Monsieur, maybe you can go first and talk about Data Club, because you know Data Club the best.
Sure. I'm Monsieur. I'm the Research Data Librarian. I've been here for since 2018, so however long that's been. I handle a bunch of different things. I don't have a particularly specific section of the data world that I focus on, but if you have questions about text mining and that sort of stuff, I will be doing a data club in 2 weeks on that, and then a few weeks after that I'll do another one that's specifically about data engineering, and we'll sort of expand a little bit of Python knowledge using pandas and polars. Pandas you may have heard of. Polars is a little bit like pandas with some changes. And yeah, Data Club has been around for a while. This year we've changed it so that it's all of RDS's workshops are under the Data Club umbrella. That's exciting, I think. And yeah.
Yeah, so
I don't know if we can do introductions because I don't want to dox anybody.
Right, I will introduce everyone's session in one of my slides later. So, but I think Eric, you probably also introduce yourself.
Yeah,
and
I'm Eric. I'm the GIS and Geospatial Librarian at Columbia. I'll be hosting a couple of these sessions around GIS and geographic.
Yeah, and Jerma.
Jeremiah Christensen. I'm head of the Research Data Services, so I will.
Yeah, so basically, this is a slide, how to contact us. So if you want to contact RDS, our email is data@library.columbia.edu. So basically, any data questions if you want to ask library, we are the contact person. So if you email data, you email 4 of us. So I will provide our personal emails in other slides, but this is the quickest way, the fastest way to contact us for any of your data questions is also about Data Club. But you can also join Data Club using those links. We will share slides with you, so you don't need to worry about you don't know how to link to that Data Club link tree or something like that. And today will be the first Data Club, and if you keep joining us, you will have a better understanding about Data Club. And again, this is 215 Lehman Library, and we will meet here every Thursday from 4:10 to 5:30 p.m. for this semester, from September to November. And here are the schedules. So as I mentioned, This is the first session, and Eric will give you introduction to GIS next week for geospatial tour. And Mozilla will have, me personally will have 2 parallel sessions about Python and R. Mozilla will focus on pandas. I will focus on how to deal with large data set. And Jeremiah will give you a very special census data session talking about American Indian and Alaska Native census data. Plus, if you never heard about what is HCOP data, that's a final session for this semester. It's a restricted access data, licensed data for Columbia affiliates about healthcare utilization. And I will give you more explanation later. So I want to start with this type of data perspective. I know many of you have used the data, but you probably don't know every single data formats. So I want to use very simple data example to broaden your data mindset. So when I, as a numeric data services librarian, I work with people. I work with them using Excel, SPSS data, R, Python for numeric data analysis, regression, statistic, algorithms. So what my role looks like, I only work for example, the left side, the structured data. So what is structured data? I use a very simple example. This is a table, right? So tabular data. And for many of you, I think you know what is spreadsheet, CSV. But how many of you know Parquet? Or how many of you know NetCDF or FASTA or other things I listed here? So that is the main point here is they are all called structured data. And when some of you mentioned you know Python, you know R, you can use those tools, even GIS tool, dealing with those structured data for sure. And when I started my job here, one of the job role in my job description is, oh, you should help with data wrangling. If people, they want to clean data, do some data preparation, that is why I call data services or research support for my job title, right? And in that way, you should think about that's because data is messy. So we want to sort it out into structured data so you can run it. But nowadays, people will say this is an AI era, so data cannot be structured, right? So as I mentioned to the right side, so there are many texted information, video, image, audio, multimedia things. People will say, AI can handle all the unstructured data. Why you still keep saying like we need to use structured data? And how about those unstructured data? And the first thing I want to emphasize is, even though I put structure, unstructured, semi-structured here, the structured here means if machine readable or not, right? So for example, I give you a sentence as an example called unstructured, but because Mozilla is a linguistic expert, they might disagree with me to say this sentence is well structured. From linguistic perspective, how do you define a sentence is unstructured data? Because this is a text data, and computer cannot read this type of sentence very well. Someone will challenge me to say, no, nowadays AI can read my prompt easily. So now AI can read all the unstructured data. So that's the next layer I want to explain here is, yes, there is something easily called natural language processing, NLP, which is very popular nowadays, and people will think NLP can deal with human language, so we don't need to worry. But actually, the hidden box for the AI tool, everyone I believe you are using in ChatGPT or what else is, we put this so-called unstructured data into the prompt. We submit it. Immediately, you get also unstructured like text information. But during the very short time, you submit your unstructured data and also receive the unstructured output or outcome, the chip, the NVIDIA chip or whatever things, they help you to process those information very quickly to change the unstructured information into structured thing in the back end. But because it's too short, you cannot read it and you cannot see it by your eyes. You might think it's unstructured, too unstructured. But actually, AI help us to finish that change from unstructured to structured, then unstructured process in a very short time. So that is why I think even though we don't need to know the hidden box, because not everyone is interested in design AI, right? We are not going to be AI experts for every single one. You have your own career pursuit or ambitions. So, but you at least need to know, even though nowadays we talk about we can deal with unstructured data easily, the final is how to convert any semi-structured or unstructured data into structured shape. So this is the first thing I hope everyone keep in your mind. So until today, I'm talking about data in September 2025 because we are going to record this. Maybe 10 years later, it's a different story. But until today, I'm talking about it. When we talk about data analysis or how to use data to change the world, we still, our final goal is to put all those messy data into structured way so that we can deal with it and change the world. And the next question here will be, why bother to have semi-structured and unstructured data? And I think for the text information, that makes sense to everyone because we are human. We need to use human language, but we need to change human language into computer-readable language, which is so-called structured. Then how about those semi-structured data I listed here? So this is a very easy, like I think, JSON format data. And I don't know how many of you used the JSON data before. Could you hands up? 1, 2, okay. And how many of you, I think most of you know HTML, right? That is just web page. So that is why we need JSON or HTML or XML, etc. Because there will be certain scenario, for example, a website. We have developer. They probably will do more structured programming, but for us, we don't need to know those things. We just need a web page as the front face for us to see and search for anything, right? So for HTML file, mostly you just use it for web browser to look for information, but you still need developer to build up a structure. So one side is for user, the other side is for developer. So that is why semi-structure is kind of a compromised way to help us link developer, user, and computer all together. And you don't need to use the same interface, but you need to know sometimes you might get data information from website. And for example, later I will show you one example, like Academic Commons, that is Columbia's open repository. Everyone, if you write dissertation or if you have any PowerPoint slides or any work papers you want to deposit in Columbia and share with anyone later, that will be a great place to put your stuff. But sometimes you probably want to retrieve information from those kind of data repository. For example, you are curious about, I graduated from SEPA, and how many people from 2000 until now, they deposited what type of research papers into their repository. So in that type of work, you can use interface to search. But when you want to download those type of information, you probably need to deal with JSON file or HTML file because those information, they are stored in their website or web pages. And once you want to analyze those type of historical data information, you probably need to deal with those semi-structured data files. If you catch up with me, that's great. If you have questions, ask me now, or I will keep repeat those type of things later, so you don't need to worry, because I will have more concrete example later in my other slides. So I want to stop here and make sure everyone can catch up with me and understand what I'm talking about. So the next thing is, based on what I mentioned just now, I want to use geospatial data as an example, because I think for most of you, you are not very, very familiar with geospatial data, right? And Eric will have 2 sessions on September 25 and November 6. One is teach you how to use geospatial data, the open source tool called QGIS. And the November 6 session will be about all different types of data formats you are going to meet with if you are dealing with geospatial mapping, those type of functions. And I give you 3 different types of things to tell you, like, even within the geospatial field, you will meet with structured data, semi-structured data, and unstructured data. I don't want to spend too much time to explain, because if you join Eric's session, Eric will give you more concrete examples and more deep explanation. But just in case you have very quick questions related to this slide, Eric is here, and feel free to just ask him now, or you can save all your geospatial questions for next week and November 6th. So another perspective I think people may or may not understand well is about what type of data we are having nowadays. So again, mostly I talk about this from researchers' perspective, but if we only talk about open data or open access data, so everyone, if you hear about open access data or public use data, they assume not just researchers can use, every single people, if they can search online, they should be able to work with those data or use those data. So here I want to, based on data access levels, I categorize data as fully open data, conditionally used data, and restricted data. So why there are 3 different types? That is because how many of you know NYC open data? 1 and 2. Okay, let me show you the NYC open data web page, so that if you never use this open data portal and you are NYC people, you absolutely need to know your local data. If you are interested in every single aspect of New York City, this is a great, like, fully open place to find data related to NYC's business, government, education, health, environment, etc. So this is absolutely fully open. Everyone can come here and come to any of the data study, and you will see, oh, maybe I'm interested in any, like, a sea level rise map. If that is the case, very interestingly, this could be, if you click like export, they will tell you you can download map in CSV format. But I assume if this is a map, really map, then you can also download it in other, like, map format Eric will introduce to you later. So if you look at here, they basically show you an Excel or CSV with the geom and ID. So I don't want to stick on this map data set too much, but my main point is, if it's Los Angeles open data or New York State open data, if you Google online, a lot of government, city government, state government, even census, they will have data.gov. So this is fully open data for this is basically the home of the US government's open data. So NYC open data is part of this portal, but if you want to know more about what is available here, you are going to see tons of data sets can be found. They are from local government and also the federal government. And if you want to narrow down the data by formats, you are going to see XML, HTML, CSV, etc. So again, you are going to see all those different data formats in public available data sets. So this is the first thing I want to emphasize. And another thing is for many of researchers, so I don't know how many of you know research reproducibility. So for example, you read an journal article, right? And nowadays, researchers will share their scripts and their data sets so that you can replicate what they did. So for example, you are interested in what they do, or you want to extend what they have found. Maybe you want to get those like code and script and do something like try on your own self, like at your end, and maybe think about some new ideas. So the next link for Open ICPSR, this is, even though a social science data repository, but I want to use it as an example for you to know, for anyone online, you can go here to find like a social science related research replication package. So for example, if I search any keywords using find data, so I can use something called maybe neural network, for example. Oh. Neural, N-E-U-R, right? And you are going to find something related to either deep learning or neural network. So for example, you are a student. You're saying, I'm learning deep learning or I'm learning neural network. I want to find some examples which can help me to polish my data skills. Can I find some data sets, or can I find some examples online I can learn from? I can maybe based on one research article and do some data analysis. So this is a repository. You can find data and code for certain publication. For example, the first one, this is the data and code for one research article they published in AEA's journal. And they will tell you what is this data related. This data and code is for a publication called Using Neural Networks to Predict Microspatial Economic Growth. So in that way, you probably can guess this thing probably is, even though economic research, but also through a spatial perspective. And again, if it's through a spatial perspective, they might use data both in numeric format and geospatial format. And here, firstly, they share their code in a folder. And you are going to see there are tons of code based on they deal with image and they process data and they train their text model. And firstly, if we go to the first folder called extract image, you are going to see they are all Python files. Mostly they are Python files. So if you don't know Python, you probably cannot run those scripts, but you know, okay, Python could be a skill set I should keep in my mind if I want to replicate or reproduce the results for this type of publication. And again, if you go to the process one, they tell you they use this to prepare their data. And if you keep checking produce results, very interestingly, you are going to see, except using Python, there are several do files. And I didn't mention do files before because do file is used in Stata. I don't know how many of you are still using Stata or you know what is Stata. So this is a statistics software. So the new generation, if you are freshman, maybe your professor just say go to R, go to Python. But if you go back 10 years ago, SPSS Stata, they are also very popular statistics software. So again, this session is to draw your mind to let you know if you want to find like something you want to reproduce, maybe those researchers, they use a different data tool, and you need to keep in mind and keep open-minded to say, like, if I want to rerun their script for example, the first one, January prediction panel, you probably need to know how to use Stata or how to open the Stata do file in that software, or you need to find someone, like for example, data librarians, to help you to explain why they use do file. Actually, it's the same. Like you can do something in Python, use the py file, but you can also use do file for Stata running. So those type of thing is just to broaden your mind. Like once you go to different disciplines, you see different researchers, they want to show you their data. It can be in different data formats and using different data tools. And the other thing I just mentioned is Columbia's academic commons, right? And as I mentioned, everyone can deposit, like Columbia affiliates can share what they do, especially if you are doctoral students, you might deposit your doctoral thesis, your dissertations here. So I think 20 years ago, we don't have this type of thing. So everyone's dissertation may be deposited in your own department. But now we have a central repository. So you can deposit there, and later, if anyone know you, they want to read your dissertation, they don't need to contact your department. They can just come to this repository and download or read the thesis here. So for example, maybe your next generation or your grandchildren, they want to know your dissertation, and you deposit it here. You don't need to contact anyone because this is an open, fully open, like a repository to any people in the world. Then you can come here to download data. And one more thing I want to show you is what I call the semi-structured data. So I use the JSON or HTML as example. So that is based on the developer resource, right? So for academic commons, what I'm showing you just now is the user front end. So you can search and download certain things manually. But for example, as I mentioned, if you want to extract all the information from this website, what can you do is through this type of thing called API. So if you go to Academic Commons API, you probably can, they will tell you, oh, you can do something to get a record. And if you try it out and search for any keyword, and they will allow you to do maybe maximum 100 records download. And you can search any keyword here. For example, if we search COVID, and we probably will know like how many things related to COVID you can search for in Academic Commons. And immediately you will see this kind of semi-structured data information related to, of course, I only set up the default as 25 records. And the maximum I know is maybe this time I can extract the first 100 records. And later, people, for you, if you are interested in text mining, you want to contact Mozilla to say, I want to extract all the COVID information from Academic Commons to do some like a sentiment analysis or whatever topic modeling. This is the first step for you. And what you can do is, look at here, you have a download button. And this will be a JSON file. So I will have an academic API workshop next semester in spring using OpenRefine, Python, and R. So there are many different tools. You can deal with JSON file, HTML file for semi-structured data analysis. But this session, this example is just to show you all the possibilities. You can find data and you can use data. Any questions so far? Okay. So these are all open data, right? When we talk about it's like fully available. And now I'm moving to the middle and the right side. So what is conditionally used data? So Jeremiah will give you a session talk about the Indian Alaska Native census data. So this data could be, I think he can explain later why this is conditional use. Because every single time, if you think about conditional use, especially I talk about US census data could be fully open, conditionally, and restricted data, I want to explain a little bit more. So everyone knows there is a census, data.census.gov, right? So we assume everyone can access census data for free. This is a public use data. But actually, there was some under certain condition, you can access data for free, but you need to go through certain process. That is because some of the data related to private information. So census absolutely keep all your confidential information there, but maybe if for researcher you want to access into very micro level, you need to submit your application so you can have it. And this is not just for census. If I have time, I will show you a research project doing the same thing. So sometimes census will save the data for maybe 10 years, then they release it because of some sensitive information. And sometimes they can share with certain researchers if you have a solid proposal. So that's why it's conditional use. And some of those information will never be released into the public. And another case will be CDC. So CDC will collect all the disease-related information, but they can only, I think, release county level or above data. You are not able to say, oh, I want to know this census tract for rare disease, how many people get that, because it will be very easy for people to detect those individuals. So for privacy protection, sometimes even you have that research interest, you need to go through certain procedures so that you can get access to those confidential data. So this is conditional use. And some of the other thing I put on the right square is called restricted data. And Mozilla will have a text mining session related to TDM Studio. So in TDM Studio, that's a product by ProQuest. So for all the ProQuest data, they are licensed data. We pay for the subscription, right? So that if you want to use all those text information provided by ProQuest, their vendor. So for example, New York Times, Washington Post, or other journal articles, you want to have tons of those text information come into your database and do certain type of research, then maybe TDM Studio is a good platform for you to think about. And Mozilla will let you know how to use text mining and even their AI tools to extract data. But because this is licensed data, so this is called restricted data. So if you are Columbia affiliate, you can use. But if you leave Columbia, you say I'm alumni or I'm just regular person, you are not allowed to use due to copyright or other data license issues. So this is why I want to bring data ethics into your attention, because this is something people easily ignore. Even though you think about, oh, website data, any web page, if I'm technically enough to scrape those data I can use, please keep in mind every single time, if you want to use API and use web scraping, talk with your professor and talk with your data librarians, because you never know if it is allowed or sometimes if it is ethical enough to use those data. And the last one is, again, I mentioned Jeremiah will have HCAP data. That is definitely medical data and highly sensitive. So for those data, Jeremiah will explain more, like for Columbia affiliates, how to access those data and what is the application process. Oops. So now we come into another perspective. I think many of you know, I mentioned AI at the beginning and deep learning, machine learning, and we are into a word, media keep talking about big data, synthetic data, data simulations, those type of terms. And in order to answer those questions, there are two kind of parallel sessions led by Mozilla and myself. One is a Python session about pandas and polars. the other R session is about large data sets, how to work with large data sets. And I can talk more about my session, and Monsieur can add more about his session. The reason I want to have a session talking about working with large data sets using R is because I want to avoid big data concept. So that is more from a data engineering perspective. But for many of you, you are not data engineering, you are just data researcher. Sometimes you only have a laptop or a workstation, right? And for data engineering, you probably will have high performance computing, cluster, all those like SQL database infrastructure to support you. But if you are just independent researcher, you want to deal with some large data analysis, can R do it? Because usually people think R is slower than Python, and R use the computer memory a lot. If you have those type of issue, can R still work with large data set? So my session will answer this question using my perspectives. Again, Data Club is not to teach you something, it's just to provide some our perspectives. So I will give you some of my personal solutions, how to use R deal with large size data sets. And I probably will also mention, maybe you reach this type of threshold, then think about HPC. Never mind to consider about work on your own workstation, something like that. And I think this is useful, especially for every single one, if you want to do some independent study. Plus, you think about what is a good timing to jump into group collaboration and ask for more infrastructure support from your research team and from Columbia. And Monsieur, do you want to talk a little bit more about your Python session here?
No.
Yep.
We'll just be talking about data engineering, which is sort of the process of taking data from the world and putting it into a format that's usable for analysis. So data engineering is the idea, stands between quote-unquote raw, there's no such thing as raw data, but quote-unquote raw data, and then analysis-ready data. So it's about cleaning, wrangling, joining, these sorts of things.
Yes, and the pandas and polars, they are two libraries.
There are two Python libraries. Pandas is very well known, polars is a little less well known.
And you are going to use Parquet as the example.
Yeah, depending.
Yeah.
Parquet it's a file format that provides certain kinds of benefits. It's over something like CSV, namely in terms of size and speed. And so it's especially good for very long data sets that have many rows and maybe not a ton of columns. That's actually also fine, yeah.
Right. So I think my session will be the same. I will introduce some libraries, packages, but you can use your own creative thinking or critical thinking to keep think about if those packages are the right options for you or not. Because you can search online, different people, different researchers, they rely on different packages. And our purpose is to introduce you to those packages, and we will show you some workflows. But if that is the best workflow or not, that really depends on different research projects. So that is why Data Club is not like a fully like an instruction thing, because instruction thing is like this is fixed knowledge. Just take it and remember, memorize, then get it. And for Data Club thing is more like we provide those options for you to think about if they are good enough for you. If not, tell us, and maybe we can have further conversation or discussion and try to figure out some solution maybe. And I talked about R, Stata, and Python, SQL even we mentioned a little bit. But I know some of you might be also interested in like a qualitative data. So I linked a qualitative data research guide here from UIUC for your information, just in case sometimes you are not just falling into quantitative data analysis, but you also have some curiosity about what is qualitative data, how to deal with qualitative data. And I believe some of you also know Tableau or Power BI. And if you don't know and you have interested in knowing more, I believe the previous data clubs also had some sessions related to JavaScript, observable, right? So those type of things I listed in the right box. We either had some sessions before, or if you are interested in knowing more, come to talk with us. We can convert them into our data club sessions in next semester in the future. But all the 8 sessions I mentioned, that will be our this semester schedule. And you are welcome to bring any other new topics to us, and we are happy to develop them into new sessions in the future. And a little bit other more information will be resources, what's available from RDS, and what is available from CUIT. So as I mentioned, we have a lot of research data guides. I will give you a link to Research Data Services. If you just search Research Data Services Columbia, you are going to find our homepage. And our research guides are all listed here under Research Guides. So for example, Eric next week will talk about GIS and geospatial data, and there are 2 LibGuides. One is how to find geospatial data. The other is to tell you the different types of software you can use for geospatial analysis. And we talk about TDM Studio a lot. And in the text mining guide, you are going to find more information about TDM Studio. And if you are interested in social media data and other text sources, that's another guide for your information. And myself has a data analysis tool guide. So I listed all the numeric data analysis tools we support currently. So if you have any questions, you are welcome to reach out to us and have like one-on-one discussion. Either you want to learn those tools or you have any questions related to those tools. So this is the first thing, we have LibGuides. And the other part, as I mentioned, maybe when you reach a threshold, your personal computer cannot help you to do any data work. Then maybe you need CUIT support. CUIT has a research computing services. I link their pages here. So you can find more related information. But the most important is, firstly, they have their high performance computing services. You can submit your request and contact them to discuss about your HPC needs. And also, for some of you might curious about what is Columbia's support about AI. So currently, CUIT do have several options to tell you how to use those AI tools or what they offer you. And you can also schedule like AI consultation with them if you have any AI-related questions, especially what kind of AI tools you are able to use, etc. So before you leave this session and before I come to the last slide, I want to show you a more concrete example why what I mentioned today is very related. And this is what I learned maybe like last week or until yesterday. I want to show you something. I believe most of you know there is a very famous report called World Happiness Report, right? So if we just say, oh, World Happiness Report, it doesn't matter where are you from. People care about like World Happiness Report, and you will find the information. And if you are data related, you probably also know this is Gallup data-based annual report. So Gallup is the data provider. They give you many different types of like public opinion data, right? And the World Happiness Report is heavily rely on Gallup. And we receive a lot of like, especially CEPA students requests about do you have Gallup? And yes, we do have the Gallup World Polls. So let me show you the Gallup portal, just in case you want to know where to find the Gallup analytics. This is the Gallup Clio portal. But this is not the most important thing I want to talk about. So because of the World Happiness Report, Gallup becomes very, seems like with a good reputation to provide good happiness index. But another research team from Harvard, nowadays, they developed something else with Gallup to provide a complementary measurement. They call it a global flourishing study, I think. Yes. So this is type of thing, if you search online, they call it a global flourishing study. So they think, okay, Gallup has some happiness measurement, which is good, but they want to extend their research. So that is, again, based on the current data-driven research. Now, this is a newly designed data-driven survey. They want to develop different 6 dimensions to define. They don't call it happiness, but they call it like flourishing index, using different perspectives, like how financially you're stable, how closely with your social network, etc., right? So if you search to the very end, you're going to see they collaborate with Gallup. So this is also a Gallup thing, but also this is a Harvard research project. And the best thing is they tell you they share data using this platform called Center for Open Science. So again, come back to what I mentioned. We have restricted level, conditionally used, and fully open data. Then the next thing, maybe for your curiosity, would be, can I get access to those data, right? If they say, oh, we share data, so, and they also show you on the Harvard homepage, they will tell you, we have our different research to get those type of, like we're doing not just a global flourishing thing, and we probably will have like a religion related, work-life balance related, and the different perspectives. So you can find more their research output based on the data they collect. And they will also tell you the data survey is available. But if you type the data is available, you probably think you can access data for free. However, based on, I think they have 5-year data, wave 1, 2, 3, 4. And now I think wave 1 and wave 2 are available. However, based on their access data page, they will tell you, yes, we share it on the open science framework without any fee. However, maybe we need to wait until spring 2026. Then every single one can access this data online. So before spring 2026, if you want to use this data, go to the OSF website and you can complete a pre-registration form. So basically, as I mentioned, that is also like a restricted level step to submit your research proposal. They will provide a code book, tell you what's available there, but tell me a reason. What is your research topic, and why do you need our research data, right? So if that is the case from mid-year 2024 until now, if you want to access this data, this is not fully open. So I use this as an example to show you, even sometimes you look at some like a research article, a news article, they say, oh, we use data from CNN, we use data from Pew Research Center. They probably will say this is open data, but when you want to use the data, you probably need to contact the data provider, and they will tell you, because this is public survey data, we will curate it and release it to the public after 6 months or 1 year or 18 months or something. That depends on the data provider's policy. So this is the first thing I want to tell you. yes, you can have data, but maybe not now. Or if you want to get access now, you need to really have a concrete research proposal so you can apply for it. And the next thing very interesting I know is, even though you think, okay, this is again a numeric data structured from time series, but based on this, there is another Harvard team now. They extend this very well-structured temporal study into geospatial, because Harvard now has something called, I think they have a GeoTweet data archive. Yes, so if you search this in Harvard Center of Geographic Analysis, they really hold something called GeoTweet archive. And this is a very large GeoTweet archive. Let's go to their Dataverse so you can learn more details about this. So again, even though before the flourishing study is a numeric longitudinal study, now they want to turn it into a social media-based geospatial analysis. So now, again, social media data from Twitter, from X, is unstructured. But because they keep this archive from 2010 until 2023, I think Mozilla can explain more, like Twitter changed their policy after that. So before that, it's still okay to download tweet data for free and unlimited. So I think that's what some researchers in Harvard, they did. They downloaded billions of geo information related social media data and now saved on Harvard's HPC cluster. So again, this is billions of data, worldwide, with longitudinal data, latitudinal data. So easily, if you learn GIS from Eric, you will know how to extract those location information. And what they are going to do is to build up a geo database and doing some AI challenge. That AI challenge, let me show you, is on i/guide.io, this platform. And I think you can log into this platform because I think Columbia is a member of this platform. And what I just want to show you is what they are doing now using the GeoTweet data to extend the, oh, I have a typo, flourishing. Right. So you are going to see they share 4 different things. Firstly, they share data sets. And the data sets they are using is what I show you, that GeoTweet data. They will use those flourishing measurement to do more geospatial analysis. And they do have a GitHub repository to talk about more details and share what they have done. And let me go to their GitHub. They will tell you this is a spatial AI challenge based on the global flourishing study. Now they try to extend it into a geography perspective, then geotemporal study about the human flourishing. And they share all their script, mostly in R and Python here. And because this is still an ongoing challenge, so it's not a well-cooked project, I show you this example to tell you some of those information are open, public. However, if you are interested in doing similar thing, you are not able to get this data because the GeoTweet archive page mentioned due to exchange their copyright thing. I think that currently, note for non-Harvard researchers, they are not able to share the 4 raw tweets data with you. However, I think after they finish this, the Geography of Human Flourishing project, they probably will share some data here. And currently, I think they share some of the sample data sets here on this iGuide platform, which is called Dataset. So of course, this is just US based. And remember, when we talk about this very huge billion-based Harvard GeoTweet archive, they have the worldwide geo information plus social media information. So I want to show you this example to show you have many potentials to do your research using data, but once you know those data formats, basic concepts, and know exactly what type of tools and methodologies you can use, then I think the data research is not that difficult. And you are welcome to talk with us more about your data-related questions, ideas. And I want to just stop my talking here. And here are a few suggestions I give to all of you. At least learn one type of data tool or programming language we mentioned today for your research. It will be easier. And if you now have any coursework or research project, just based on that, don't jump into any data sets you feel curious but you don't have time to do. And if you feel very anxious or uncomfortable about anything related to data, come to talk with us, and we are here to help you. And I want to leave more time here for open discussion or for your questions.